Welcome back, friends. Let me help you with another complicated problem which is associated with the mechanical energy. So in this question, it's given as the roller coaster trolley with the mass of 600 kg coasts down the first hill and it drops a vertical distance of 45 meters from the initial height of 51 meters. So there is a trolley which is at a height of 51 meters with respect to the ground. So this is the 51 meters given to us, 51 meters. And then if at the bottom of the hill it is at a speed of 30 meters per second, the speed of the trolley at the bottom of the hill is 30 meters per second. When it reaches here, it is at 30 meters per second because it's coming down to a height of 45 meters starting from this point. If this is the reference point, it is going downwards at a height of 45 meters. And then what is the trolley's mechanical energy relative to the top of the hill? So I wanted to find the mechanical energy at this point relative to the top of the hill. So if I ask you a question, if the trolley is here, what is the mechanical energy relative to this point? So relative to this point, the mechanical energy will be equal to 0. Relative to this point, the mechanical energy will be something like, maybe if let's say this is stationary, so it will be mgh. So again, that's the most important concept in this, that when you are finding the mechanical energy, you have to have the reference plane. So now I wanted to find, I'm going to name it as location. I'll change the color. So this is location 2 and this is location 1. So I wanted to find the mechanical energy at location 2 with respect to the location 1. So mechanical energy will be equal to, again the formula will remain same, potential energy which is mgh plus kinetic energy which is half mv square, and mass is 600 kgs times 9.81 times height value will be, in this case, is it is moving downwards from this reference plane. It is going height, we are moving in the downward direction, so anything moving downwards we'll consider it as negative, so that energy is taken out of the system, plus half times mass value given to me is again 600 times velocity is 30 square. And now I'm gonna calculate the value. So pardon me, I don't have my calculator with me, so what I'm gonna do is I'm gonna use my phone to calculate these values. So this is 600 times 9.81 times negative 45, which comes out to be 264,978 plus, and this value will be negative, this is 0.5 times, so this value will be 0.5 times 600 times 900, because 30 square is 900, which is 270,000. Now if I look into what the final value will be, 270,000 minus 264978, so the value comes out to be 5022. So that's the mechanical energy. If I wanted to write it in the scientific form, I can write it as 5.02 times 10 raised to the power 1 2 3, 10 raised to the power 3, and then this will be joules. So we figured out the first part. Now in the second part, what is the relative trolley's mechanical energy relative to the ground? So this will be pretty straightforward. Relative to the ground, I wanted to find with respect to this point, what is its mechanical energy. So mechanical energy relative to the ground, me, equal to, again, potential energy plus kinetic energy. So this value will be equal to, potential energy with respect to the ground is how much? This is mgh. Again, height, now the height, we're moving in the upward direction, height will consider as positive, so 600 times 9.81 times height is height in this case will be 6, because 51 minus 45 will give me 6 meters, plus half times mass value is again 600 times this is 30, because at location 1 it is still moving at 30 meters per second. So 30 square. Now this value will remain the same, 270,000, and then this value will come out to be to do this calculation. So this value comes out to be 600. Oops, I have to restart it. 600 times 9.81 times 6, which comes out to be 35316 plus 270,000. So this value comes out to be, the final mechanical energy value will be 305,316 joules. Hopefully you were able to understand another concept of the mechanical energy. I'll see you with another video. Bye now.